Okay, so concept zero in continuity is the notion that the volume flow rate, if you've got a laminar flow, that is flow that's not swirling around, it's just all going in a straight line, all at the same speed, okay, down a pipe, that the laminar flow is the area, the cross-sectional area of that pipe times the velocity. So that's the velocity in meters per second, and this is the cross-sectional area. Okay, and the reason for that is that if you think of this little cylinder there, right, that little cylinder, the volume of that cylinder is going to be just the area of that times that change in length. We'll call it change in length 1, right? And the volume flow rate, which is the cubic meters per second, is what it is, right? It's going to be how many cubic meters go by every second, is just going to be that divided by time. Well, if you look in the parentheses there, that's just distance divided by time. That's velocity. So it's just area times velocity. So if this has a cross-sectional area, say 4 square meters, and it's moving at 2 meters per second, right? You've got, well, 4 times 2, that'd be 8 cubic meters a second going by. If this has a area of 3 square meters, sorry, did I say cubic before? Square meters, and it's moving at 5 meters per second. Well, 3 times 5, that'd be 15 cubic meters a second, okay? So let's see, what's the volume flow rate of air moving at 1.3 meters per second down a hallway that measures 3.2 by 4.10 meters, right? So our area is going to be 3.2 times 4.1 meters. That's 13.12 square meters. And then our flow rate is going to be area times velocity, right? Or what do we call this? The volume flow rate, I'll say V over T, right? And this is a big V, not the velocity, right? This is just a big volume, right? Velocity, or volume divided by time is area times velocity, right? So that is 13.12 square meters, right? Times 1.3 meters per second. Now look at the units, right? You end up with cubic meters per second. So that times 1.3 is 17.056, and that's cubic meters every second, right? So that's our volume flow rate. That's somewhat aggressive, right? This is, by the way, a very large ventilation shaft, right? So let's imagine that we're changing the air in a room. That is, that this air is going into a room, and the air is maybe exiting the room somewhere else. And so we want to change the air in a room that measures this by this by this, right? Okay, so the volume of that is literally, we just go this times this times this, right? So 10.2 times 14.0 times 5.2 is 742.56. This is roughly the volume of my classroom. That's cubic meters, right? Okay, so that's the volume. And then the volume flow rate, all we have to do is divide the total volume by the volume flow rate. So it's kind of like there's another formula here that we're all sort of pointing at, right? What would it be? Flow rate? Flow rate is just volume over time. So therefore, time would be volume divided by flow rate, right? So time is going to be the volume, the 742.56. divided by the flow rate, right? So this is cubic meters, right? And this is how many cubic meters you go out of the room every second, right? So I'm just going to go that divided by this guy and get 43.5 seconds. This, by the way, is somewhat aggressive, I think. You know, I think they do air. They really, honestly, God, they talk about like air changes per hour, the heating and ventilating, or per minute or something like that. And maybe it's like 3 or 4 times an hour you change the air in a room. I really don't know, but that's a thing. Okay, let's take a look at the next thing. For in the next video, I'll show you how to do what we really do with this area times velocity thing. Okay.